Alright guys, let's knock out this practice test video, test number 6 in Precal. First three say find the domain of the function. Remember, domain is almost always all reals, about 90% of the times it's all reals. The only time we got to worry about is if there's a fraction or an even radical, even root, like number 3. Number 2, there is a fraction. There's two things that x cannot equal, and that is negative 7 and 5. So I'm going to say all x such that x cannot equal negative 7 and 5. Number 3, a radical. Remember, you must have a positive number inside a radical, so I'm going to take the x squared minus 16. I shouldn't say positive, just say non-negative. It can't be 0 either. Set it greater than or equal to 0. I'm going to factor that, make it x plus 4, x minus 4. Sorry about the clicking. I'll use my Apple Pencil. Draw a sign graph, have a negative 4 and a positive 4. Plugging 100 like we always do. It's going to be a plus here, a minus there, and a plus there. And because I'm looking for greater than 0, my domain is going to be everything less than negative 4 and also everything greater than positive 4, including the 4, because it's okay if it equals 0. Right, number 4, graph it. I know for a fact because there's a square, it's going to be a parabola. I got to find some points. I'm going to plug in some points to find out what works, what points are going to be on there. Remember, the reason these points are on the graph is because they work in the equation. Okay, so let's go with, I don't know, let's pick in some smart numbers here. Let's go like negative 4 for x, because that's going to give me a 0. So negative 4, negative 5. Negative 3 would be 1 squared minus 4 is negative 4. Negative 2 plus 4 is 2 squared, which is 4 minus 5 is negative 1. Let's go negative 1. If I go negative 1 plus 4, that's 3 squared. 9 minus 4 is 4. Good night. Plug a 2 in there. 2 plus 4 is 6. 6 squared is 36 minus. That's way too big. So that's probably enough. Let's go. Let's plot these real quick. Negative 4, negative 5, right there. Negative 3, 1, 2, 3. Negative 4, right there. Negative 2, negative 1. Negative 1, 4. And I did 2. I didn't do 2. Probably ought to go a little bit past negative 4. Let me do a couple more. Let's go to negative 5. We'll pick a negative 5. A negative 5 plus 4 is negative 1 squared is 1. Minus 5 is negative 4. So negative 5 is also negative 4, which is going to be right there. You can start seeing the parabola pretty well now. Negative 6 would be negative 2 squared, which is 4. Minus 5 is negative 1. So negative 6 is negative 1. You can definitely see the parabola taking shape here. So I'm just going to go ahead and connect the dots. Not a very good one, but there's my parabola. Number 5, it's a radical function, which means I know my graph is going to do like half of a sideways parabola, opening that way. Be smart what you plug in here so you get things that haven't, where the square root actually works out real well. So I'm going to plug in 2 first for x. 2 minus 2 is 0. 0 plus 3 is 3. I'm going to plug in, let me think here. Let's plug in 3, because 3 minus 2 is 1. The square root of 1 is 1, plus 3 is 4. Be smart again, be smart. I'm going to plug in 6, because if I plug in 6, 6 minus 4 is, that's not very, sorry, 6 minus 2 is 4. The square root of 4 is 2. 2 plus 3 is 5. Let's do one more here. Let's plug in, well, I don't know. I was going to say we could plug in 11. That's pretty big. 11 minus 2 is 9. Square root of 9 is 3, plus 3 is 6. Let's try those. 2, 3 is right there. 3, 4 is right there. 6, 5, let's see. 4, 5, 6, 1, 2, 3, 4. Sorry about me counting out loud. 11, 6 is probably off my graph a little bit. So it's going to look just like that right there. All right, number 6 is piecewise. I'm going to blow this up a little bit and see a little better. There we go. Best way to start piecewise is to take the number that they give you on the left and plug it in. So we're going to go negative 1. Plug it in there, negative 1. How we get positive 1? So we're going negative 1, positive 1. Put a point at negative 1, positive 1 right there. Sorry for my squeaky chair here if you can hear that. I'm also looking, it says the plug-in thing's less than negative 1. So I'm going to go ahead, since I know that's a line because there's no exponent, I'm going to plug in negative 2. Negative 2 plus 2 is 0, so that's going to be 0. Plug in negative 3. Negative 3 plus 2 is negative 1. And you can see what the line's doing. And because it starts at negative 1 is going to the left, I'm drawing that line, or at least part of that line going that way right there. That's the first part of the piecewise. The second part, again, plug in negative 1 for the x squared. Negative 1 squared is positive 1, so negative 1, 1, which is, I already have a point there. It should be an empty circle here, but it's already filled in circle, so I'm not going to worry about that. I'm going to plug in a 0 next. If I plug in 0, 0 squared is 0. Plug in a 1, 1 squared is 1, plug in 2, 2 squared is 4, and you can see this the part of a parabola. That's x squared is always a parabola, and it's only the part of the parabola that goes from -1, so it's going to look like this, right through those points. And there's your piecewise. All right. Number 7 and 8 both say use the vertical line test to determine if it's a function or not. Number 7 fails quickly. If I draw a vertical line, it hits it twice. That's a no, not a function. Not a function for sure. Number 8, I can draw a vertical line anywhere. And I can just hit this function. It never goes vertical. It gets close to being vertical right there, but not quite. So that one is a function for sure. Number 9, determine whether that determines y as a function of x. When I do these, I like to get y on the side by itself, so I'm going to switch places with the y and the 4. Basically what I'm doing is I'm just switching sides here with the y and the 4, make it 3y minus 4. And what I'm looking at right there, because it's x squared, in my head, because of what we've done this week, I know that that's a parabola. And if it's a parabola, the graph is going to be doing this. Okay, I know it's going to be doing that. So what that means is I know it's going to pass the vertical line test, so it is going to be a function. But the other thing I know is no matter what I plug in for x, if I plug in 1 for x, I'm going to get 1y. If I plug in -2 for x, I'm only getting one answer for y. If I plug in 0 for x, I'm only getting one answer for y. So because every x has exactly one y, that is definitely a function. So 7, 8, 9, just are they functions? Are they not? That's the worst looking word function I've ever written in my life, but it does say function. All right, number 10. Number 10, simplify. I keep going back to this, a fraction and a fraction. And what you're going to have to do, you got to multiply the whole numerator and denominator by the LCD, which is 3x. So if I do the numerator, I'm going to do this term first. If I do that, the x's cancel. That leaves 2 times 3, which is 6. If I do this term, the 3's cancel. It leaves -1 times x, which is -x. In my denominator, I'm going to just distribute 3x times x and 3x times 3. Now, just for safety's sake, I'm going to go ahead and factor that denominator because I can. And if I do that, I get x plus 3. Now, nothing cancels, so I'm officially done right there. I know a couple of you are like, yes, it does. It doesn't cancel. Don't cancel. Maybe you can only cancel factors. So be careful there. All right. Number 11. Bunch of values to plug into this function. First one's f of 2. If I plug in f of 2, I'm just going to put a 2 in the square root where the x is. That gives me 1. 3 times the square root of 1, which is 1, by the way, is 3. F of 1, I'm going to plug in a 1. 1 minus 1 is 0, so I'm really doing 3 times 0, which is 0. F of 17, that's a unique number, but this is a very smart number to plug in because if you plug a 17 in there, it gives you square root of 16, which is 4. 3 times 4 is 12. And you got it. I'm going to skip to the f of 10. I'm going to do the fraction last. F of 10, if I plug in 10, 10 minus 1 is 9. You get 3 on the times square root of 9, which is 3 times 3, which is 9. And the last one, I'm going to erase the ones I have here and make some room for this one. Give me just 1 second to do that. There we go. Okay, f of 3 halves, sorry. If I do f of 3 halves, I'm getting 3 times 3 halves minus 1. 3 halves minus 1 is 1 half. So I get 3 times the square root of 1 half. Remember, that is really this. That's really the square root of 1 over the square root of 2. The square root of 1, by the way, is 1. So I'm really looking at, this is going to get crazy here for a second. I'm really looking at this now. And remember how we simplify that. You take the radical to the numerator, take the number on the bottom, 3 on 2 over 2. And there's that one. Number 12. It says solve here. I'm going to multiply through by the LCD. First of all, I should say this first. First of all, tell what x cannot equal. X cannot equal 0 or -2. So let's go multiply the whole thing by x and x plus 2, every single term. Now the first term, the x's would cancel. That was going to give me 3 times x plus 2. The second term, the x plus 2 is going to cancel. It gives me a 5 times an x. On the right side, nothing at all cancels. So I have 2x times x plus 2. Then it just become a bunch of algebra here. We're going to solve this equation, do all the algebra steps you know. Distribute twice there. That's a square. Now, because I have a square in there, you know, my brain's going, oh, I got a factor. I've got a factor. So I've got a 3x and a 5x, that's 8x. If I move the 8x over, it gives me a negative 4x. Move the 6, that's a minus 6. They're all even, so I'm going to take out a 2 out of everything. Make it a little bit easier to factor. Now I'm thinking what factors of negative 3 give me negative 2, be a minus 3 and a plus 1. Come in. And then my two answers may be 3 and negative 1. Remember, you got to check those. And when I say check, I mean make sure they're not those that we put earlier, and they're not. So there's your two solutions, 3 and negative 1. 13 is a definite quadratic. It's got a square, so automatically I'm thinking, okay, I'm going to factor probably. So I'm pulling everything over. I'm pulling the 5x over and the 1 over. Now, if I do slide, divide, slide, if I try it, and here's what I'll ask you to do. When you try that, if you slide the 3, it's not looking too good because I can't think of any factors of 3 that are going to add up to be 5. Like there's not any. So that means I'm going quadratic formula here. So I'm going x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, just like that. Work out what's inside your radical. I think it's going to be 37 in there, which is, I know it's ugly, but it's also very nice because you can't break it down, and because you can't break it down, you're done, right? It's really great that it doesn't break down in a way because, I mean, your answer is not that beautiful, but at the same time, saves you quite a bit of work. 14, the last one. Finally, first of all, a lot of times what I ask you to do, it's kind of up to you here, is do inside work if you can. Meaning, I can't do anything with the x, the 8. I can't do anything with the 16, but there's a y in my numerator and denominator, and the big one's on the bottom. I'm going to go ahead and flip that down there. So negative 4 is really 12 thirds. So if I do 12 thirds plus 4 thirds, that's 16 thirds. So I'm going to go ahead and move that down there, make that 16 thirds. I still have this negative 1/4. Remember, the negative 1/4 goes for everything inside. If you want to do this, the negative flips everything inside. So I'm going to go ahead and flip everything. I'm going to have 16 y to the 16 thirds power. On the bottom, I would have x to the 8th power, and it's still just to the, whoa, sorry about that, I'm not sure what happened, to the 1/4 now, positive 1/4. And remember, the exponent on the outside goes for everything inside. If you do 16 to the 1/4, that really means the 4th root of 16. You can punch it in if you need to. But the 4th root of 16 is 2, because 2 to the 4th power is 16. On the y, the 4, if I do 16 thirds times 1/4, which I'm multiplying the exponents here, that cancels. I just get 4 thirds, so I get y to the 4 thirds. And if I do 8 times 1/4, that is 2, so I get x squared. And there you go. That's as simple as you can get. Hope that helps you some. Hope you use this a lot. Do great tomorrow. Can't wait to see you. Make some awesome test scores. See you then. Bye.